Hello, mathematicians. Welcome to lesson 31. In this first day, our first session is all about angles, and we're going to learn a little bit about measuring angles and a little bit about naming angles. So it's all about angles all week. Here we go. Start with asking yourself whether each angle is acute, right, or obtuse. So what do you think about this one? Yes, I agree. That one is obtuse. And what about this one? Yep, this one you can put the little square symbol in there because it is a right angle. It is 90 degrees. Looks like a corner, and it is. And then this one over here is acute because the angle is smaller. We measure angles from ray to ray, and that distance in between there is less than 90. Nicely done. All right, in your books, on page, let me hide this for a second. On page 673, here is our try it problem. Lily and Dora each turn the hour hand on a clock face. They make different angles by turning the hour hand. Who makes the greater angle? Explain how you know. Okay. So we've got a clock here. They're both right there. Lily goes from here to here. Dora goes from here, from 12 o'clock all the way down to, I guess, the 12 and the 4. So we have 3 o'clock and a 4 o'clock. What's the problem about? I agree. It's about clocks. So that's our first read. Yep, the problem is about clocks. Second read, we're going to answer the question, what are we trying to find out? Lily and Dora each turn the hour hand on a clock face. They make different angles by turning the hour hand. Who makes the greater angle? Explain how you know. So what are we trying to find out? Who makes the greater angle? And then, of course, we want to add proof because that's how we roll. And the last read, we are looking for important information. Lily and Dora each turn the hour hand on the clock face. They make different angles by turning the hour hand. Who makes the greater angle? Explain how you know. So it looks like the big thing is we've got this one. We've got Lily and Dora. Lily goes to 3 and Dora goes to 4. All right. So that's our important information, is to know the difference between the two clocks. Here are some tools they suggest for solving it. If you've got a clock, you can literally just move the angles, or just a clock face picture. Index cards and sticky notes can help you use reference tool. So like if I use this like an index card, watch me as I give this a go. I can put that right in there and I can see it looks like exactly 90 degrees. So using this tool, not even using the protractor yet, just using this corner tool, which could be an index card or a sticky note, I can tell that Lily's at 90 degrees. And if I put this over here, I can tell that Dora goes beyond 90 degrees. The opening there goes beyond. It's bigger than 90. All right, so then I can write in my answer. So Lily would be 90 degrees. Can't remember what my command is for degree symbol. So I'll write the word degrees. And Dora is greater than 90 degrees. Or obtuse, you could label it as obtuse. And then my proof is right there. So I could leave my proof there. I could even maybe copy this to have 2 of these. Command D. I'm using a different computer than I usually do because I like to have a few more tools. So I don't have the touch screen, but I could use the tool. So that seems to work out well. So there's my proof in the picture. You can see 90, greater than 90. So who makes the greater angle? Dora is the answer. So Dora. All right, next one on page 673. Ask your partner, how did you get started? Okay, so I started by using the index card. That's the strategy that I did. So I'm not sure what you did, but that is one way to give it a go. All right. Explain how you know who makes the greater angle. Okay, so that's where I would just, I guess, type in my explanation and see. How do I know that Dora, okay, so Dora has the greater angle because, oops, spell it right. I used the corner of I used the corner of a rectangle, but it could be like an index card, whatever you used, or maybe you used projector, or maybe you were just able to look at it and tell. It's the corner of a rectangle to measure the difference. It's typing so. And I'm going to put so Dora was exactly 90 degrees. And, oh, not Dora, Lily. By Dora, I mean Lily. Thanks for catching that for me. Lily was exactly 90 degrees, and Dora's angle was greater than 90 degrees. And then I started yelling by caps. Okay. You know what I mean? So something like that, or however you proved it, put your connections to explain your thinking. Next one on page 674. You can measure angles to compare them. A degree is a unit of measure for angles. Show degrees with the symbol degree, which is that little tiny circle, which I was trying to type in, but I don't know it on my menu. I'll have to look that up. The angle made by a full turn of a ray in a circle measures 360. Okay, so that's just that idea. Like if you completely turn yourself all the way around, that's a 360. So a complete circle is 360 degrees, which you can see in this picture here, right? Look at the diagram below. An angle that turns 360 of a circle is called a 1 degree angle. Okay, so you can see right here, little tiny measurement right there. You can also kind of see it in my handy dandy protractor, and you have a circle protractor too, so that this would be a good time to pull that out and to look at that. So this is a half a circle, so this measures 180 degrees. And each one of the little tiny lines, I'm going to make this a little bigger so you can see it. Maybe I am. So here's 0 degrees, and these little tiny lines right here, 1, 2, 3, 4, this is 10, 20, 30, 40, 50, 60, 70, 80, and then there's 90. And then once I get to 90, now it goes to 100. So these numbers right here are if you are measuring from this side. So it's just like when you measure with like a ruler, you always start at 0. So if you're not sure, like, which number do I start with? You start with 0. You don't start with 180 and count backwards. When you measure, you start with 0, and then you count up to wherever the line is. The red angle in the diagram turns through part of a circle. Okay, so this red angle, oh, this one right here is going through part of a circle. There's 1 degree, and it's going up. Okay, write the measure. Oh, okay, so I guess you'd have to count that. It might be easier for you to see on page 674 because it looks very, very small to me, but I'll do my best. So that is 1. Whoops, that's annoying. 1, 2, 3, 4, 5, 6, 7. To me, it looks like 7 degrees. So you look and see what you think that is. And I'm going to put 7, and then I'm going to write the little degree symbol the best that I can. 7 degrees. A ray turns to form a right angle in the circle at the right. Okay, so this ray is going from here to here. What is the measure in degrees of the right angle? Okay, so that's how angles are measured. We have a perfect 90, which is, you can see, it's 1/4 of a circle. So what's 1/4 of 360? That's where they get that 90, huh? Sorry, I'm using the touchpad and that's a little harder to write, but yes, 1/4 of 360 is 90. Okay, so it's not rocket science. It is all mathematical, makes sense. 90, that's why a 180 is half a circle, right? And a complete circle is 360. It all makes sense. Number 3 on page 674 is a reflection question. How does the way a ray, I'm trying to get this out of the way. How does the way a ray turns through a circle help you think about the measure of an angle? Okay, so if we have a circle, we do, because we are using our tools today. And the question is, how does the way a ray, and we can probably pull out a ray. Let's go find a ray here. There's a ray. Rays start from the middle of the circle and point out. Very nice. Very nice. How does the way that a ray turns through a circle help you think about the measurement of the angle? So we don't really need the protractor today. That you will use later. But how does the way a ray moves through a circle help you think about the measure of an angle? Okay, so if I'm going to move this, let's see if it lets me move it. And if this would move around the circle, I don't know if it's going to let me move it. Well, I guess that would be a negative. I wonder if I can make it bigger, go outside of it. Okay, so if this green arrow would move around the circle, how does it help you think about degrees? And maybe this does help on here, because if you had a ray here and you moved it through the circle, you can see it go from 0 to 10 to 20, 30, 40. So as it opens up, it makes a different, it measures it in degrees. So something important to remember is sometimes students get confused on, it doesn't matter what size the circle is, they all have 360 degrees because you're measuring the opening, and all circles are 360 degrees. So it doesn't matter if it's a little circle or a big circle, because half a circle is always 180, 1/4 of a circle is always 90. It does not matter what size circle. It just matters that it's a circle. Okay, so keep that in mind as you give it a go. All right, cool beans. So that's page, let's see, do we have one more? Oh, we do. We have one more thing to do on page 675, because you're going to do 675 and 676 on your own. Here we go. So put degree in your vocabulary there. And you're going to put some examples. So you probably want to put a circle, because where does the degree come from? Circles. It's all about the circles, measuring the circles, measuring the angles. So put this in there, and then you might want to just remind yourself that this is a 360 degrees. So I'm going to put 360. I'm going to write the word degrees because I am typing, but you can just put the symbol in because that's what mathematicians would do. Other examples of degree. I would probably put in the different kinds of angles that you know. Draw yourself a right angle, draw yourself an acute angle. Maybe I'll just type in those words and you can give that a go. So draw a picture of an acute, acute angle, and do an obtuse and right angle, because you definitely need to know those and be able to label them. And then it helps you. What's another example of the word degree? Maybe you just want to put in words like it literally measures the distance between two rays. So that would be in there. So distance between two rays. That's what it's measuring, the distance between two rays. Okay? And it does not matter what size circle. And you need at least one more example. You probably already have one. I guess you could just draw another angle and you could just estimate the degrees. So you could just draw maybe show 1 degree. That might be kind of cool, or show 180, something like that. All right, mathematicians, you get to finish page 675 and 676 and enjoy your angle work. Bye, mathematicians.